Hello guys, in this video I'm explaining the concepts related to thread, what is actually a thread, what is multi-threading, and the important multi-threading models. Right? So let me start with the introduction. So what is thread? A thread is nothing but a basic unit of CPU utilization. Now you can ask a question, what is the meaning of CPU utilization? When your CPU will be utilized? When you do some task, your CPU will be utilized. A thread is a basic unit where you are going to do some task to utilize the CPU, right? And a thread is going to consist of thread ID. Mainly it is used to identify the thread. Not only the thread ID, a thread can contain a program counter, a stack, and a set of registers, right? Now we will see into this in detail. Now you can see here, this is an example of a thread. This thread is going to do a addition of two numbers. It is a simple thread. It is going to do the addition of two numbers. You can see there, this thread contains a stack. In that stack we have thread ID. For thread ID, why we need thread ID? To identify the different threads, I need a thread ID. Here my thread ID is 11. Right? This thread ID contains, this thread contains a stack. Stack contains a code. You can see there is a code. You can see there is a code to add the two numbers. Not only that, thread contains a PC. PC means program counter. Program counter always having the address of the next instruction. Here, what is the value of a PC? 1, because add is equal to a plus b. Add a plus b is the instruction. That's why the PC value is 1 here. Not only that, thread contains the registers. Registers are mainly used to store the values. To store the value of a, that is 10. To store the value of b, that is 22. Right guys? So understood, right? So this is the simple structure of a thread. So you can see there, a thread is a basic unit of CPU utilization. That means you are going to do some task. Here I am adding the two numbers, thereby I am utilizing the CPU. Each thread is associated with a particular task. Right? You can see here, each thread will have a program counter, a stack, and a set of registers and a thread ID. Here you can see there, thread ID is there 11, and we have a code part where we have two variables and one instruction. That's why PC value is 1, and those variable value is stored in the register, and all these contents are stored in a stack. Understood guys? So what is a thread? So it is a basic unit of CPU utilization, right? Now see here. So what is multi-threading? What is a single thread and what is a multi-thread? So see here, traditional processors, that means old processors, will have a single thread of control. Here this is the example for a traditional thread. Traditional thread, that is a process having only one thread. Here this process is going to do only one task using a one thread, that is adding of two numbers. You can see here, single threaded process. Here the thread, what is the thread is there, it's going to do only one task. You can see there, that thread is having a stack, the thread is having a register, the thread is having a data, code, etc. Understanding guys? So traditional, that means before one process will have only one thread. Earlier processes, right, where there is only one program counter, one sequence of instructions that can be carried out at any given time. Understood guys? You can do only one task. Process can do only one task using one thread. But what is a multi-threaded application? Multi-threaded application means there is a single process, but single process can contain multiple threads. You can see here, there is only one process, but it can contain multiple threads here. But in the previous example, only one thread was there, but here in this process it contains multiple threads, where each thread will have the register, stack, code, right? So you can see there the best example to make it understand in a more better way, right? I'm going to give an example of a MS Word, right? In a MS Word application, you know that you can type something, right? You can type something and you can create a file, right? MS Word is a one process, but in MS Word we can have multiple threads. For example, in MS Word I can use one thread to type something. Here I'm typing Vishesh CIT. In the same way, I can use another thread to check the spelling. Here my spelling Kaveri is wrong. I'm using the spelling checking thread to check the spelling, that is CAUVERY. Along with that, I'm using one more thread to insert the image. Here I'm using three threads, but that is only one process. MS Word is only one process, but I am using one thread for typing, one thread for spelling check, one thread is for inserting the image. You can see there only one process is there, but different threads are used to do different tasks. This is multi-threading. That's why I told you in multi-threading model, right? The data, the code will be shared. You can ask a question, how? MS Word is a one process, right? But typing feature is also using the MS Word memory only. Spelling check is also using the MS Word memory only. Insert image thread is also using the MS Word memory only. That means these threads are using the same memory of the MS Word. These threads are sharing the memory resource. Understanding, guys? That's why. So these program counter, stack, everything will be shared between the different threads. You can see here these three threads are using the same CPU time of the MS Word, same memory of the MS Word. Understood, guys? If you have any doubts, please post your doubts in the comment section. Right? Next. Why? What is the motivation behind the multi-threading model? Right? Only one thread is enough to do a task, but why we need multiple threads? What is the use of it? Right? You can see here what is the motivation behind it. Threads are very useful in modern programming, right? Whenever a process has multiple tasks to perform independently of the others. Obviously, when you want to do multiple tasks independently, you can see there, here I am doing multiple tasks. So when you want to do multiple tasks, right, you need threads. That's why to do this I need threads. And one more important thing, this is particularly true when one of the tasks may block and it is desired to allow other tasks to proceed without blocking. Here, when you use multiple threads, you can block one thread and you can allow other threads to perform. Right? That is also possible. If there is only one thread, it is not a. If you block one thread, the whole process will be blocked, right? But here it's not a case. If you have multiple threads, even if one thread is not working, you can continue with the other threads. For example, in MS Word, if a spelling checking is not working, no problem. You can continue with the insert image and typing, right? So that's why multiple threads, right? It will be useful for you for this task. For example, the same example I'm taking here. See here, in a word processor, a background thread may check spelling and a grammar, while the foreground thread process can use for typing the keys, and another thread may be used to load the images. Understanding, guys? Threads can be used in foreground and background also. You can allow one process to continue, one thread to continue, and you can block the other thread in a process, right? And one more thing, in a web server means what? You know that server means it is going to serve the request from the clients. Here you can see there can be request from multiple clients, right? For example, see here, multiple requests to be served simultaneously. How? A thread is created to service a request. Meanwhile, another thread listens for more client requests. You can see here client, right? Client means, suppose, assume that I am requesting something from the server. So when I request something to process that request, I'm going to create one more thread, right? And again I can create one more thread for listening additional client request. Here I'm not stopping for listening the client request. No, I'm not stopping that. When I'm allocating one thread to process my request, in the same time I'm using the another thread to take up the multiple requests from multiple clients. Understanding, guys? So multiple threads. One is busy in processing my request, but another thread is busy in listening for the other clients. That means it may accept other requests from other clients, right? So see here, that is the same thing here. In web browser also, not only in the server, in web browser also, one is used to display the image and another one is used to retrieve the data from the server. That is possible. In web browser also I can use multiple threads to do multiple tasks in the same way as web server, where in a web server it can serve my request, along with that it can wait for the other clients to send the request. In the same way in web browser also I can use one thread to display the image and another thread to retrieve the data from the network. So this is the motivation behind the threads, right? That's why we designed a multi-threading architecture. Now, advantages. Why we need threads, multi-threading, especially why we need multi-threading? Because in a single threading architecture, if a thread blocks, the process will stop. But we need to do multiple tasks. What is the advantage? First advantage in multi-threading is responsiveness. For example, one thread may provide rapid response while other threads are blocked or slowed down during the intensive calculations. For example, responsiveness means my task is divided into different subtasks, and each subtask is assigned different threads. My task will be completed very fast, right? That's why responsiveness will be very high, because I'm not dependent on only one thread to do the task. I have multiple threads. Each thread is going to do particular task, and obviously my task is definitely finished more fastly. That's why multi-threading allows a program to continue running. And another advantage, even if one thread is blocked, I can continue with the other threads, right? That's why it will improve the responsiveness. I don't want to shut down the entire process here. Understood, guys? That is one advantage. Next advantage is resource sharing. That means you know that every thread share a common resource such as code, data, and other resources, right? So when you are sharing the resources, it allows the multiple threads to be performed simultaneously, right? You are sharing the resources means you can allow multiple threads to execute simultaneously. In MS Word example, you have seen that. So multiple threads executing simultaneously, thereby your task is going to be completed very quickly, because all of these threads are sharing the resources. You see, their memory of the MS Word, CPU time of the MS Word, all those resources are shared by these threads, thereby resource sharing, efficient resource sharing is possible here. Efficient resource sharing is possible here. So what is the next advantage? Economy. Creating and managing threads is much faster than performing the same task for processes. For example, context switching. Context switching means you can switch between different threads. You can move between the threads. For example, in the MS Word application, you can move from typing to spelling check thread, spelling check to insert image thread, or again you can move from insert image to typing thread. You can switch between the threads. That is context switching. So if you do context switch, obviously you can manage the threads very easily. Obviously it may lead to the reduced cost. right? Cost will be reduced, economy will be very less, right? Because you can easily create and managing threads in a much faster way. You can switch between the threads, obviously it will reduce the cost, right? You can do your task more efficiently, thereby it will reduce the cost. Understanding, guys? Next is scalability. So what is scalability? Scalability means you can utilize the multiprocessor architecture. For example, multi-threading can be greatly utilized in a multiprocessor architecture. For example, in a single threaded process, it can use only one CPU, but whereas the execution of multi-threaded application, right, you can use multiple CPUs. That means you can create, right, as many threads as you want, right? You can create as many threads as you want, thereby you can increase the concurrency. That means multiple users can use the multiple threads simultaneously, right? Even if you create the threads, it doesn't affect the operation. It doesn't affect the operation, right? Even if you create multiple threads, you can continue your operations without any problem, right? Without restrictions also you can create the threads. Scalable, you can create as many threads as you want, right? But practically some OSs may restrict the creation of threads to around 200 300. No, sometimes, but theoretically you can create any number of threads, thereby you can scalable, you can improve the performance, you can scale it, right? Multi-threading on a multi-CPU machine increases concurrency. Concurrency means multiple users can use multiple threads at the same time. But even if you are using a single processor architecture, the CPU generally moves between each thread so quickly. That is also an advantage. Even if in a single processor architecture, if your thread is moving quickly, it will give the illusion of parallelism. That means I am only using the CPU. They will think like that, but parallelism will be there. That means others also use the CPU at the same time. Understanding, guys? So these are the advantages. So first advantage is responsiveness, resource sharing. Responsiveness means, so even if one thread is blocked, you can continue with the other threads. Thereby you can complete your task fastly. Responsiveness will be there. Resource sharing. When you create a multiple threads can use the same resource. Thereby you can efficiently use the resource. Economy. If you create and manage multiple threads, obviously your task will be completed faster. Obviously it will reduce the cost. Scalability, where you can create multiple threads for multiple tasks, thereby you can allow multiple users to use the system simultaneously. Even if the number of threads are created simultaneously, no problem will arise, right? Understood, guys? Right. Now, multi-threading model, very important. So there are two types of threads to be managed in a modern system. Now you know what is a thread, but in threads there are two types: user thread and a kernel thread. So what is a user thread? User threads are the threads that application programmers would put into their programs. That means users, the programmers who created the software, they will create the threads. For example, MS Word. In MS Word, the three threads what we discussed, the threads are created by the user, the application programmer, not by the OS, right? They are supported above the kernel, without the kernel support. For that, we don't need any kernel support, right? They are user threads. Understanding, guys? In MS Word, application programmer created the threads. But what is a kernel thread? Kernel threads are supported within the kernel of the OS. All modern OS supports kernel level threads, allowing the kernel to perform multiple tasks simultaneously. Here, user thread is different, kernel thread is different. Kernel thread means these threads are created by OS itself to do the tasks that are related to operating system. For example, device driver, to maintain the device driver, to allocate the memory, For those things, OS can create the separate threads. Understanding, guys? User thread means as a programmer I am creating my threads to do the task for me. Kernel is going to create the threads for its right itself. So OS can support the kernel threads. Understood, guys? Right? And one more important thing, user threads must be mapped to the kernel threads. That means user thread should use the kernel thread also, obviously, right? They has to map, user thread has to be mapped to the kernel thread. Now we will see that, right? So why we have to map user threads and the kernel threads? Now we will see that. Understood, guys? So first model is many-to-one model. That means many user thread will be there, but only one kernel thread will be there. Many-to-one model means many user thread will be there, but one kernel thread will be there. Why? Why may we use many-to-one model? See, in many-to-one model, many user level threads are all mapped onto a single kernel thread. Many user threads is going to map into the single kernel thread. Why? Why we do like this? Why we do like this means user space is handled very efficiently here. How? See here, if a blocking system call is made by one of the threads, here the problem is if one thread is blocked, the entire threads will be blocked. That means you can't execute the remaining threads here, right? Only one user thread can access the kernel at a time. Here so many user threads are there, but only one thread can use the kernel at a time because only one kernel thread is there. Suppose if you block only one thread, it may result in blocking of all the other threads. That is the disadvantage. You can ask a question. In MS Word, there are 3 threads, right? In many-to-one model, only one thread can use the kernel at the same time, not the remaining 2 threads. Spelling checking and the insert image thread, they can't use the kernel thread. No, it is really impossible. Because only one thread can use the kernel thread or kernel at a, right? Only one thread can use that kernel at a time, right? So that's why the threads are unable to run in parallel. Parallel processing is not possible here. In MS Word, many-to-one model is not supported because parallel you can't support spelling checking. Parallel you can't support insert imaging. Parallel you can't do that. Why means only one user process, right, has to execute one kernel thread. Understanding, guys? So MS Word doesn't come into this category. Right? Understood? So example for this is a Polaris operating system. Next. So one-to-one model. One-to-one model means for one user thread, there will be one kernel thread. For each user thread, there will be each kernel thread will be there. Understood, guys? For one user thread, one kernel thread will be there. This is one-to-one model. See here, the one-to-one model creates a separate kernel thread to handle each user thread. For example, MS Word. Here, for each thread, you can use one kernel threads. It is possible. MS Word can be implemented here in one-to-one model. That is possible because for each thread there will be separate kernel thread. For each user thread there will be separate kernel thread. It is possible. And one more important thing, in the previous model, blocking was there. For example, if one thread was blocked, entire other threads is going to be blocked as well, right? Blocking the other user threads. If one thread is blocked, other user threads also blocked in many-to-one model. But in one-to-one model, it overcomes the problem of blocking, because if one user thread is blocked, you can't block the other threads because there is a separate kernel thread for separate process. You can continue with the other threads. That's why blocking is overcome here. Next, but the problem here is managing of the overhead, right? Because you have to manage each threads, single thread needs to be managed. That's why slow down, the system will slow down. Understood, guys? Because there will be separate thread for separate user, right? That's why each thread, each user thread and each kernel thread needs to be managed. This will create the overhead, management overhead. Thereby it will reduce the speed. Thereby it will reduce the speed. And one more important thing here, you have to place a limit on the number of threads. Yes, you practically you can create it, but theoretically you can create it, but practically you have to place a limit. Yes, you can create the threads, any number of threads, but it will slow down it, right? Slow down the operation of the system, right? That's why you have to limit the number of threads. You can create it, but if you place a limit on the number of threads, it will be useful. Understood, guys? So here blocking will not there, and for each user thread, one kernel thread will be there. For each user thread, kernel thread will be there. Example, Windows XP, right? Windows XP, Linux, these are the examples for one-to-one model. Now, many-to-many model. Many-to-many model means, see here, so you can have any number of many user threads for many kernel threads. So see here, let me see, it's simple. The many-to-many model multiplexes any number of user threads onto a equal or smaller number of kernel threads. In many-to-many model, for each user thread, there will be equal number of kernel threads, or smaller than that also possible, not more than that. For example, if 3 user threads are there, there can be 3 kernel threads, or 2, lesser than 3 also possible, but higher than that not possible. Here in many-to-many model, we are combining the best features of one-to-one and many-to-one models. We are combining the features of both these models, that is one-to-one model and many-to-one model. Understood, guys? Many-to-many model means there can be any number of user threads. To that user thread, there can be equal or smaller number of kernel threads. Here, users have no restrictions on the number of threads created. But in the previous case, I told you have to restrict the number of threads created. But in this case, I don't have any restrictions to create the thread. So MS Word can be implemented in many-to-many model also. Right? It is possible. Blocking kernel system calls do not block the entire process. Here also blocking won't be there, because there is no restrictions, right? Even if one thread is not working, I can continue with the other threads. I can continue my operation with the other threads. And one more important thing, process can be split across multiple processors. That means threads can be shared between multiple processors. So for example, some threads will be in one processor and other threads will be in other processor. You can share the threads between different processors. For example, if you are implementing MS Word, one thread can be in one processor and remaining 2 threads can be in another processor. That is possible. Why we need this means it will improve the resource utilization, right? And one more thing here, individual process may be allocated variable number of kernel threads, right? Depending upon the number of CPUs present and other factors. That means multiple threads, kernel threads, can be allocated to the individual process. That means one process can contain multiple kernel threads. For one user thread, you can have multiple threads also. That is possible. For many user threads, many kernel threads also possible. That is right? It is possible, because many kernel threads is supported for one user thread also. Many to many, yeah, it is many to many, right? for you can allocate many kernel threads for many user threads. That is possible. One process can contain multiple kernel threads. Right here, one-to-one model, user process, one user thread will have only one kernel thread. Right? But here it's not the case. One user thread can have multiple kernel threads. Here also you can see there in the diagram, one user thread can have multiple kernel threads. That is the difference. Understood, guys? Don't get confused. In many-to-one model, multiple user threads will have only one kernel thread, but in one-to-one model, one user thread will have one kernel thread, but in many-to-many model, one user thread can have many kernel threads. Understanding, guys? So you can allocate more number of kernel to a single user thread. It is possible in this many-to-many model, but in one-to-one model, one user thread, one kernel thread. In many-to-one model, multiple user threads but very one kernel thread. But here, many-to-many model, for one user thread you can allocate multiple kernel threads. Understood the difference? Right. And one more important thing, this model is also called as two-tier model. Right? Next, this many-to-many model examples, real world examples can be HP UX, TRU64 Unix. These are the operating system that supports many-to-many model. So understood, guys? Let me brief. So in many-to-one model, for many user thread, only one kernel thread will be there. Right? Because only one kernel thread is supported. So if one thread is not working, the entire process will be blocked here. That is the disadvantage. But in one-to-one model, for each user thread there will be kernel thread. Here no blocking will be there, because for each user thread there will be one kernel thread, not more than that. For one thread, one user thread, one kernel thread. But in many-to-many model, for one user thread you can allocate more than one number of kernel threads. Here also there won't be any blocking. Right? Here also there won't be any blocking, because you can allocate multiple kernel threads for one user thread. That is possible. So hope you understood the concepts, guys. Thank you for watching the video. Please don't forget to subscribe to my channel. Please click the bell icon to get the notifications, and don't forget to like and share.